Jai Hind. My name is Vikas, Assistant Professor in Department of Computer Science Engineering. The topic that today I am going to discuss is Bloom filter in the data analytics subject is there. This is the index of my presentation. What is Bloom filter? What is the working principles? What are the problem on Bloom filters that we can solve it, which generally comes into the university exams are there. So, what is Bloom filter is basically this is in a probabilistic data structure that is highly space efficient and used to test whether the element is a member of a set is there. That we can identify that whatever the elements that come that we have received or an application that received, they first check whether that given data sets, given data is present in the their database or not. Generally, these type of things happens when in data analytics we have the large amount of the data that we receive. We have to check whether we have the duplicates data that is being received or not. So, in order to provide the faster executions, they basically check whether that the given items or given data is present there or not. So, in this Bloom filter, we will basically check whether the given element is the member of a let's suppose there is given set is there. So, it can return the there are certain things that happens in the Bloom filter is that it never give you a false negative, but it can give you the false positives are there. So, this makes it suitable for applications where this small kind of error is being acceptable, but the memory efficiency is basically is plays a critical part is there. At that time, we use this Bloom filter in order to identify whether the given item, whether the given element is available in the present data set or database or you can say member of that set is there. This is a working principle is there. And generally in the Bloom filter, we consist of array of elements in the form of bits are there. And initially we initialize all these elements in zeros are there. And we multiply those bits by the hash functions are there, which is hash function is being defined by the data expert is there or the users are there. So, when an element is added to Bloom filter, it has to pass through all the hash functions are there, and each hash functions, after passing through the hash functions, whatever the output is that define the position of the in the bit array is there. The bit of these positions are then set to the 1 is there. Okay, we will take an examples how this principle works are there. Another point is that to check whether the element in the sets, in the given the set is there, that element has to pass through the same hash function which is previously is being used in order to put the value of the bit array or you can say positions in the bit array is there. Same way, in order to check whether the element is present in that particular given set is there. So, it has to pass through the same hash functions is there and in order to identify whether that bit, whether that element or data is present in the array there or not are there. So, if all the corresponding bits are set to 1, then we say element is considered to be in the given set is there. Okay. So, though there are chances of false positives in the Bloom filter is there, as I already told you that it gives you the false positives there are there. So, after checking it, if that bit is present and all the after going through the hash functions, all the bits are ones, then we can say that bit is basically that data is present in the given set is there. So, where we generally use this Bloom filter in order to use, in order to identify the data are there. So generally use cases in data analytics for the Bloom filter is to find the set membership testing is there. Bloom filter are used to quickly check whether an element is present in the large data sets are there. This particularly useful for a task such as deduplications, cache lookups, and ensuring that uniqueness in the data streams are there. Generally, the thing is what we have to do as when we talk about the data analytics is there, we have the large, huge amount terabytes of data is being generally is being generated daily is there, and in that daily generation of data, now the companies have to identify whether the given data or whether the given elements that they have received is duplicates or not, or that has to be present in there or not are there. So they have to check whether the given data is there. Why did they have to check? So that they can provide the better accuracy is there, better timely manners in order to provide the values, or you can say in order to provide the better solutions in quick manners to the users are there. So the first test case use cases set membership testing is there. Another is web caching is there. So as our network systems are nowadays distributed systems are there. So in distributed caching systems, Bloom filters are used to check if the URLs or objects are already been stored in the cache is there. So by reducing the unnecessary retrieval operations are there. So what they will basically see whether the given when we search any URL on the web browsers are there. So first time you search it, write that web browsers, write that URL in that web browsers, and you open that websites. After that opening the websites, again that will come same manners that the cache is being stored in their systems, and it automatically helps you to find the that website, and they provide the faster manners on that open websites are there. Same way, the web caching is plays an important role in the your web cachings are there. Another use case is data cleaning and duplications is there. When processing of the large data sets are there, Bloom filters helps in identifying the duplicates items with the minimum memory overheads are there. So by ensuring the efficient memory management during the data cleaning tasks are there. So as I already told you that we in daily day to day, the companies are receiving terabytes, petabytes of data are being there, and on the basis of the data that they received, they receive many times the duplicate data are there. So in order to identify those the things, elements, data, so they have to identify the whether the given data is already being present or not or that. If they are being present, so whatever the data is being come, we compare it whether there is any changes in that data. If there is no changes, then that will be clean is there. Another distributed systems, Bloom filters are commonly used in distributed data while database file systems are there. Like your Apache, Cassandra, Google Big tables are there. So to avoid unnecessary disk read by checking the existence of key before queryings are there. Okay, so as the we have the huge amount of data is being generated, they have this store in very different locations are there. So the systems will check whether the data is being duplicately available in our different distributed data servers are there, or you can say database are there before giving the any output are there. So they basically checks those data, and they have to make sure that whether the if they don't do it, then they have to read the disk again and again. So it will again, it creates a more time, and it will take more time in order to read those data are there. As we already know that the data is already there, so we just know where that data is being present, and they fetch the data is there. Another stream processing. So, data streams when the large amount of real-time data need to be processed. Bloom filters can help filter out that, know the unique or know the quick elements quickly by that will help to improve the performance of the stream analytics are there. In the streams where the continuously the data is being coming, and now that data has to be processed are there. What they do, they store that data temporarily in file locations are there, and they check whether this current data that has been received is already available or not or there. If that is available, so they know that this data is already been, so they can discard it, and they already know that data is there. So, on the basis of that data, they provide the real time analysis of that data is there. What are the advantage? Why we need what would the benefit of doing such things are there? First thing is space efficiency is there, another is fast lookup is there. When we say space efficiency, which requires significantly less memory than traditional data structures of the set membership is there, making it ideal for the memory constrained environments are there. Okay, so this helps, this Bloom filter helps us to identify whether the given data is there or not. So, as we already have the that element or that data is there, why we need to store again and again same type of data is there. So, that will create a redundancy is there. So, as another thing is when the systems having the memory, less memory as comparatively in order to require large memory is there, at that time the space efficiency plays an important role. This Bloom filter helps us to significantly reduce the less memory, or you can say require the less memory than the traditional data structures are there. As we have the already know that elements is already being there, so we able to fast look up the data is there. So, constant time complexity of the both insertions and lookup make it suitable for the real time applications are there. So, we can easily faster or manners we can access the data, we retrieve the data is there, we can also insert the data there once we have the whatever the data is being received are there. How that basically happens? Let's suppose we have this is the system is there, we have these are the streams of data. Data is being received. So, here this basically one here the data is being let's suppose data is being received here. These particular data is being stored temporarily somewhere in the server. Let's suppose this is the server is there. Here the temporary this is the temporary temporary memory is there where the data is being stored. Now, once the data is being stored, now they check whether this any given data is present, already being present in this your memory is there. If that is being present, they say this is already being there and that those data is being will be discarded, and the new data which is not being there here, so that will be stored here in this case. So, that's in this manners they already have the space requirement are also being utilized, or you can say space efficiency is being provided, and faster lookup is also being there when the any queries comes. Let's suppose here any query came is there, so that we can able to easily identify those queries are there. So, what is the limitations there? False positive. as we know that they cannot provide the negative values, but they can provide the false positive values are there. So, Bloom filter may report that element is present in the given sets when it is not, though there can slightly error can be there, which can be controlled by the adjusting the size of the filters and the number of the hash functions are there. Note, listen, once the element is added, it cannot be removed unless a more complex variants like counting Bloom filters is being used are there. So, as in previous examples, so once the data is being stored here in this case, or you can say permanently stored here in this case, so we don't delete that data is there, because that data may be needed today, data may be needed tomorrow or day after tomorrow is there. So, we have to keep that data is there until unless we have the more complex variants is there, which is being having the higher priorities, and their space is being one of the constraints are there, then that can be removed. That this is the one of the limitations with respect to the Bloom filters are there. So, let us take examples. In this examples, what we do, we having the three elements that we first we have to insert that those three elements are there. After inserting those elements, now we have to identify the how we are going to insert by using the hash functions are there. After inserting the hash functions are there, now we have to find whether the any given values, let's suppose new value has come. Now, that new value is being present there or not are there. As already told you that if all the values are being present there, then we say that element is being present. In order to identify that element, that again has to pass through the hash functions are there. So, let us take examples. So, here you are given the set of three elements are there. Let us suppose x1, x2, x3 are there that you want to store in the Bloom filter with the bit array size of m is equal to 10 and k3 is the hash functions are there. So, the hash functions are being defined as here in this case h1x is equal to the 2x more 10 are there, then S2x is equal to 3x plus 5 more 10s are there, and S3x is equal to 5x plus 7 more 10s are there. So, initially we are inserting the S is equal to 1 to 5 and 8 elements in the set bit of arrays are there, where the values where the bit array size is 10 is there, means the 10 bits values are being there in a set is there where the 10 elements can be inserted. Initially what we do, we are inserting the 3 elements are there in the Bloom filters, in that set. Then by the Bloom filters, we have to determine the final bit array is there. Once that after inserting it, pass through all these hash functions are there, what are their positions that we identified, then we can create a final bit array is there. Then we have to check. So after inserting, now we have to check another elements. Let's suppose another elements comes that x4 is equal to 7 is being present there in the given bit array is there. Okay. So, as the steps are already being defined to do, so let me go through again those steps so that working principles is there. So, Bloom filters is basically bit array. So, in this examples we have the all the elements are being initialized 0 is there. When you push the new elements, then that has to pass through the all the hash functions are there, and each hash functions after whatever the values being there, they will generate an positions where that in bit array is being present there, and we bit positions set as that to the ones is there. So, if after that is being set, now we have to check whether if the element is there in set is there when new elements comes, and we have to see whether that that elements is being there. If that elements are there and all the values after passing through all the hash function, all the values are ones, we can say that element is present. Otherwise, we say that element is not being present there. So let's go to the example. This is the example. So solve. So initialize the bit array. Start with the empty bit array of size m is equal to 10 here. So we create a bit array is there where the 10 elements are being defined here. And the index value here is being start with the 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so we'll insert. So the first element that we are inserting is x1 is equal to 1 is there. So we have to calculate the hash functions for each for the given values is there. So for h1, 2 into 1 into 3 plus, so plus 3 more 10 is there. So 2, 1, 2 plus 5, 5 more 10 is 5 values is there. 3 plus 1, 3 into 1 plus 5 is there. So 3 into 1, 3 plus 5, 8, the more 10 is 8 here in this case. 5 into 1, that is 5 plus 7, 12, more 10 is value is 2 here in this case. So 5, 8, sorry, and 2 values are being there. So we have to set the values at these positions. So 5, 0, 1, 2, 3, 4, 5. So we set the value is 1, 8, 5, 6, 7, 8. 8 being set is 1 and 2, 0, 1, 2. So initially values that 1 x is equal to 1 is being inserted. After passing through those hash functions, we have identified the positions where that element has to be present and inserted. So we insert the values, and we then what we do, we convert the value of 0 into the 1 into those positions. So we identify when we are inserting the x is equal to 1, 5, 8, 2 are the positions where the values will be converted into the ones are there. Now let's take another values that we have to insert, that is x value 5 is there. So x5 is being, now we have to calculate. Again same value, h1 5, h2 5, h3 5 are there. Again the hash functions which is already being defined. 2 into 5, 5 to the 10 plus 3, 13, more 10 is 3 here in this case. 3 into 5, 15 plus 5, 20, the more 10 is 0 here in this case. 5 into 5, 25 plus 7, 32 is equal to more 10 is equal to 2 here. So we have identified the corresponding bit values where the data positions there where we can insert the data is there. So 3, 2, 1 here in this case. Now as in this previous examples, let's suppose the 0, 1, 1 is there. So we have received third position. So it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So third positions 0, 1, 2, 3. 3 is previously 0 is there. So we convert it to the 1 here in this case. Now the 10 is for the S2, the value is 0. So we convert this at insert the value at 0th locations, and initially that value is 0. Now it will convert it to the 1 here. Now the third S3 is that 2 is we already have the 1 positions. So we that already being inserted the values at that positions. So so 2 position will remain unchanged here in this case. Now here we are saying not we are not checking, we are just inserting the values here in this case. Now we have to insert the another element, that is x3 is equal to 8 is there. So x3 is 8 has been calculated. So h1 8, h2 8 and s3 8 are there, same value. So we have to 2 into 8, 16 plus 19, more 10, 9 is there. 3 into 8 plus 5, more 10, we get the 9 here is value is there. 5 into 8 plus 7, the more 10 is where the value is there. So corresponding bits positions where that element will be present, that is 9, 9 and 7 positions are there. Now we have to check whether the given elements are being there or not. So first is 9. So as this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is there. 9 initially was 0. So we convert their position as the 1 here in this case. For the S2 we check, as we already have 9 positions, as we on 9 we already insert the value, or we can say we set the bit value is 1 is there. So that will remain unchanged, no need to. Then we have the 7 is there, then we 7 values 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. 7 is there. So value is being the sent and inserted. So here so this will come as the final bit array positions, bit array solutions, or you can say bit array values are there. After inserting the values there, all the 3 values are being inserted, which are passed through those hash functions are there. Now we have to check whether the x4, now another element comes. Now we have to check, we are not inserting the values, we are checking whether the given value is being present there or not are there. So as this is your final bit array size is there, in which in the different positions the elements are being converted from 0 to 1s are there. So these at those positions the elements are being present there. Now we have to check whether the positions at the this element has to be checked is present there or not. For what? Again we have to calculate the x4 is equal to 7, and that has to pass through those hash values are there. So we have h1, h7, h2, 7, h3, 7s are there. 2 into 7 plus 3 more 10, we receive the value is 7 is there. 3 into 7 plus 5, and on that we apply the more 10 is there, that value will be 6 here in this case. 5 into 7s, then plus 7, that will give to the more 10 is there, then it will give you the value is 2 here in this case. Now we have to check. So we have to check, we receive these values. Okay. Now we have to check whether at that positions what are the values are there. So we have to check whether at the position 7 what is the value is there. So let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 for the simplicity. 7, we have the 7, the position is 1. We say okay. For the S2, the 6 positions, the value is 0. We find the value 0 is there. For the S3 is there, the value is 2. Position 2, we have to check whether the value is there. So position 7, we have the value 1 is there. For the position 6, we have the value is 0 is there. For the position 2, we have the value is 1 is there. As per the Bloom filters rules, we say if all the values, whatever the hash functions that we use, passing through those hash functions, we have the value is 1. Bit array is there, that value must be 1 is there. If the all values are being 1, then we can say that value is being present. But in this case, this position 1, okay, at this position 0 is there, then it's not present. At this position is 1, then we say that element, that for that we checking the presence of x4, that is 7, is there or not. So in this case, in this example, as we don't have all the values are 1, we say this value is being not present in that given data sets are there, or you can say in this bit array is there. If this position value is 1 here in this, let's suppose before finding we insert the values are there. After inserting the value, if this positions, let's suppose this position value is 1 here in this case, then and we check that the 6 position value is 1, and while inserting this value 7, then we can say if all the values going through the hash function, all the values are 1, then we can say that elements is being present in the that bit array is there. So again, so this is very complicated things are there where we have to check whether the given elements are there. So in this your university exams are there, only these type of questions are being comes where we have to identify, first we have to insert the elements, then after inserting elements, then we have to check whether the given any elements is being present there or not. There are various way through which we can identify are there. We can also say we create generally another method is where we generally what we do, we don't take the hash functions, we have to convert those numbers. Here we had a bit arrays are there, we convert into binary numbers are there, then in those binary how many numbers of ones are there, that we check the count of ones are there, and on the basis of those ones we calculate whether the given elements are being present there or not. So this is the way, apart from Bloom filters, different elements, different methods are also being there in order to identify the whether the given elements are being there or not. So Bloom filter is one of them. In this this type of questions will comes. So in Bloom filter, first thing is we take the bit array is there, whatever the given size is given to you. Now on the basis of that size, you identify or define the size. We initially keep the values zeros there. We insert one by one the values are there. Those values are passed through the 2 or 3 hash functions are there, values are there, and we identify the positions. After passing through those positions, we convert those bit array 0, which is being initially zeros are there, to the ones are there. Then after inserting it, now we have to check whether the given elements is being there. Again, that has to pass through those hash functions. We identify the positions. Now we check at those positions whether the given value is 1 or not. If the after passing through all the hash functions, all the values, all the positions on which the values are ones are there, then we say that element is there in that bit array. If any of the values, and after passing through the hash function, any of the values is being 0, then we say that that value is not being present in that given bit array is there. So students, you have to go through it, these type of questions, take the different kind of questions on this. This type of questions only comes in the exams are there. So we have concluded that X4 is not present in this filter. So final bit array is there, and the Bloom filter successfully insert 158 is there, and the X7 is not being present in the filter. So this will store the process of inserting the elements into Bloom filter by using Bloom filter and checking the presence of the element using the multiple hash functions are there in the. Thank you.